Today's farmers are facing increased production costs at a time of growing public concern about the impact of agriculture on water quality. To stay ahead in this complex environment, forward-thinking producers are looking for ways to irrigate more uniformly, with less labor, less water loss, and less leaching of nitrate and agrochemicals to groundwater. Surge irrigation is a fairly new technology that is helping many furrow irrigators do a better job of applying water. However, experience shows that installing a surge valve is no guarantee of automatically reaping all the potential benefits. Irrigators have to learn how to manage surge for a wide range of conditions that occur from one year to the next. The use of surge in many different situations has led to differing points of view about its benefits and how to manage it.
I don't know, I got a lot of indecision about them because we don't have any square fields around here. Our rows are all different lengths, and this sandy soil, I don't know how it'd work if you get your rows to go through right, or you know, if the sandy soil makes any difference. And just not sure. I'd like to give one a try, but yet I don't want to have to spend the money to get the extra pipe to have to lay it out to the center of the field, and then not find out that it wouldn't work quite right, or what we'd want to do.
We're kind of short on water here, and we was having a pretty hard time to keep the field wet with conventional. And with the surge valve, we've been able to decrease the amount of water used and yet get across the field a lot faster.
First situation I used a valve in was on a sandy, very sandy, loamy soil that it was flat, had some pockets in the field, and it just didn't work. I was better off just opening up the gates and pushing the rows through, and it seemed to work a lot better. With the valve, they wanted to just set and soak, and I just couldn't get any irrigation water through the field.
Surge has been a real good tool for me. Yeah, very good. It used to take us about 5 days to get over every field, and now I'm getting over in somewhere between 2.5 and 3. And so I could take care of most of the irrigation myself, where we used to take about 2 guys to irrigate about 800 acres.
There are several important differences between surge and conventional furrow irrigation. Probably the most obvious is the layout of sets in the field. Furrow irrigators are accustomed to watering adjacent sets of rows, one after the other, across the field. On a typical quarter-mile run, sets are changed once or twice a day. For surge irrigation, a surge valve is installed about halfway across the top of the field. The water supply feeds into the valve, which directs the flow alternately between one side and the other. For a rectangular field, half of the rows in each set are on the left side of the valve and half on the right. When the set is changed, gates are set on both sides of the valve. Then the next 2 half sets are irrigated, and so on across the field. When a field is converted to surge, the number of rows per set may be larger than for conventional irrigation. For our example field, the conventional system has 8 sets for the first irrigation, while surge on the same size field only has 6. A surge set will have a larger furrow flow rate, the gallons per minute per furrow, than a conventional set on the same field, even though the surge set has more rows. This is because at any moment, water is going to only half the rows in the surge set. The larger furrow flow moves water down the rows faster. This gets water through the field with less on time and improves the uniformity of water distribution. There are many differences between conventional and surge regarding when and how long water is on the soil surface in different parts of the field. This affects which points along the row get the most water. We'll compare the 2 systems for an irrigation on a quarter-mile run. The flow rate from the well will be the same for both systems. For the conventional system, the size of the set is determined by the number of gates opened. The objective is to advance the water to the lower end fast enough to provide some soak time before changing to the next set, generally 12 hours. If it's a first irrigation, the soil surface is often very loose and cloddy. It may take most of the set time just to get water to the end. During the soak time, runoff goes to a reuse pit, or if the lower end of the rows is diked, the tailwater will be backed up behind the dike. When the set is changed, recession usually occurs within half an hour to an hour along the entire length of the row. Now let's compare this with surge irrigation for conditions where surge works well. When irrigation begins, the surge valve directs the water to the rows on one side of the set. We'll begin on the left. The same sized water supply used by the conventional system is now being put into fewer rows. Each row will have a higher flow rate, advancing water faster down the field. When the water has advanced about a fourth of the way through the field, the valve switches the flow to the right. As irrigation begins on the right, the first recession starts on the left. Recession after the first advance cycle is fast, since the water has not been in the furrow long. When water reaches the first quarter point on the right, the surge valve switches back to the left. Recession starts on the right, and the second advance begins on the left. This time, water surges very quickly over the soil surface wetted by the first advance. Then it continues down the dry furrow to the middle of the field. The advance time to reach the next quarter point increases as water advances down the field, just like conventional irrigation. The surge valve continues to alternately shift water left and right as both sides of the set advance to the lower end of the field. Here's an example of surge advance times on a field where runoff is reused. Advance time for the fourth quarter is over 3 times longer than for the first quarter. The advance on time is 172 minutes for each side, giving a total advance time of about 5 3/4 hours for the set. In this example, 4 advance cycles were used on quarter-mile rows. However, 4 is not a magic number. If rows are short or the water moves quickly, 3 cycles may work better. For longer rows, 5 to 8 cycles may do a better job. After the advance cycles are completed on both sides, the surge valve controller shifts to the cutback, or soak mode. Cutback gives the lower end of the field soak time to finish filling the root zone without excessive runoff. During cutback, short-duration surge cycles are used to alternately pulse water down each side of the set. Cutback cycles are often short enough that water may be turned off before it reaches the lower end. But if the cycle length is about right, there will be enough water in the furrow to push it through to the end. If water gets completely to the end of a row during advance, inflow during each cutback cycle usually will run to the lower end again and give some runoff. If the length of the cutback is about right, the runoff may be less in comparison to a conventional system. There, high flow rates and short set times are used to get high uniformity. It's important to get most rows through with the advance cycles. The shorter cutback cycles may not send enough water to push a lagging row through to the end, especially if it's very far behind. If on time during a cutback cycle is too long, runoff may be high. If on time is too short, there may not be enough water running through to soak the lower end. The irrigator may have to adjust the length of the cutback to avoid either excess runoff or a water shortage at the lower end. How long should a cutback cycle be? A good starting point is to set the cutback on time at about 20% of the total advance on time for one side. In our example, the advance on time was 172 minutes per side. The cutback on time for one side would be 20% of that, or about 34 minutes. A full cutback cycle would total 68 minutes, 34 minutes on and 34 off. After the advance is completed, the irrigator needs to check the first set to see how the cutback is working. Most surge valves make it easy to adjust the cutback on time. If there is a lot of runoff, cutback cycle length can be reduced. If there is only a trickle from the hard rows and little or nothing from the soft rows, cutback cycle time should be increased. How much of the irrigation should be for advance and how much for cutback? If runoff is reused, we can apply the less than half rule after the first irrigation. To get a uniform water application, the advance should take a little less than half of the total irrigation time. The other half should be in the cutback mode. For the first irrigation, this rule needs to be modified slightly to avoid over-irrigating the lower end. The advance can take up to 60 or 65% of the total irrigation time. For our example field, the total advance time was about 5 3/4 hours. If we strictly apply the less than half rule, about the same amount of time, or a little more, should be devoted to cutback. Dividing the total advance time by the cutback cycle time suggests that 5 cycles might be needed to get a reasonably uniform irrigation. Advance plus cutback requires about 11.5 hours for the whole set. We'll see later how we might adjust this to do a better job on the first irrigation. Now, let's compare the distribution of water in the soil for a typical conventional irrigation with the distribution for well-managed surge. We'll begin with the first irrigation on a medium textured soil. On the conventional system, the irrigator opens 60 gates on a 1,000 gallon per minute well, giving about 16.5 gallons per minute in each furrow. Let's watch the infiltration pattern develop in the soil profile along the row. As the flow moves down the furrow, the position of the wetting front in the soil will be marked at each quarter point. Since the root zone is still shallow at this crop growth stage, the moisture deficit is only 2 inches. Any intake over 2 inches will cause root zone drainage and nitrate loss. By the time water gets to the lower end, the top of the field is already over-irrigated. The set is changed after 12 hours and recession takes another hour. Nearly 5 inches were applied, with less than 3% running off. Only the very lower end of the field gets about the right amount of water. Irrigation efficiency is only 42%. Root zone drainage averages almost 2 3/4 inches. This causes over 20 pounds of nitrogen leaching loss under average conditions. For the same 1,000-gallon well, the surge set is a third larger, 80 rows instead of 60. But since only half the rows get water at any one time, the furrow flow rate is increased to 25 gallons per minute, 50% more than the conventional. To show the difference in intake patterns between the two systems, we'll compare the depth of the wetting fronts as the water reaches each quarter. The white dashed lines show the depth of wetting on the conventional system that we saw earlier. The advance to the first quarter point is a few minutes faster for the surge system than the conventional, since the furrow flow rate is higher. The first recession is also fast. The difference continues to grow with each advance cycle. The faster advance surges gets the water to the lower end before the 2-inch deficit is met at the top of the field. After the last advance, the cutback or soak cycles begin to fill the root zone at the lower end and runoff begins. Each cutback adds more water to the bottom of the field than the top, since the upper end has been wet long enough that the intake rate has decreased substantially. During the first irrigation, there may be more runoff from a well-managed surge system than from a typical conventional system where the irrigator is just barely getting the rows through before changing sets. Advance is faster for surge and runoff starts sooner. However, we expect much less root zone drainage and nitrate leaching. Now, let's sum up the comparison. On time per side for the surge is less than half the on time for the conventional. The total amount of water applied is about 1.5 inches less for surge, and the average intake is almost 2 inches less. Root zone drainage is about 2 inches less, and there is much less nitrogen loss. Although there was more runoff from surge because of the faster advance, irrigation efficiency was increased almost 26% since runoff was reused. The problem is that if the less than half rule is strictly applied during the first irrigation, the field may be uniformly over-irrigated. The first time over, cutback time should be only 35 to 45% of the total irrigation time, especially if the furrows are soft. If we stop at 3 cutbacks instead of 5 on the first irrigation, the excess application will be only about a ½ inch at the top of the field and will be slightly under-irrigated at the bottom. Runoff will be a little less and efficiency will be above 80%. It's also quite possible to do a better job with conventional irrigation than we've seen here. By opening fewer gates and going to a shorter set time, efficiency could be substantially increased if runoff is reused. However, this takes more time and labor than most producers are willing to devote to the job. We've talked about how higher furrow flow rates under surge get water through the field faster. If soil conditions are right, there can also be a surge effect that makes the distribution even more uniform along the row. If the surface of the furrow is relatively loose, like it might be during a first irrigation, the surge effect is more likely to occur. Wetting the soil surface during advance and then letting the water soak in for a few minutes during each recession may partially seal the soil surface and reduce the intake rate. This helps cut excess intake at the top of the field, leaving more water to flow on down the furrow. The advance gets to the other end even faster, giving a more uniform distribution. University of Nebraska researchers have found a surge effect in about half of the field trials they have run. The average reduction in on time to advance water through the field has been 17%, but individual cases have been up to 52%. The probability of getting a surge effect is highest during the first irrigation. On medium to coarser textured soils such as sandy loams or loamy sands, a surge effect may occur during any irrigation, even if the furrow surface is fairly solid. Surge irrigation has been very effective on these soils in increasing irrigation efficiency throughout the growing season. Surge lets irrigators do a better job regardless of whether they get the surge effect. They can use higher furrow flow rates to get a quick advance and short cutback cycles to reduce runoff, while making only 2 set changes per day. An irrigator with a conventional system can do a good job, but in many cases will have to spend scarce time and labor to manage shorter set times. There are some irrigators who use the surge valve only as a way to let them change gates once a day instead of twice. If they have been running a 60-row set for 12 hours with a conventional system, they now water 60 rows at a time in each side of the valve, with a 12-hour on time for each side. With this system, labor savings is the primary gain. The irrigation will have about the same efficiency and the same nitrogen leaching loss as the conventional irrigation. There are some situations where surge has no apparent value, and in a few cases has seemed to make things worse. For example, when surge irrigation is used on land with very flat slopes and with a surface in poor shape for irrigation, it has not been very successful. Some problem fields have stretches of nearly zero slope with depressions several inches deep that have to fill before the water can run on down the row. The advance is slower, and there is little or no recession between surges. In general, surge has worked well on sandy soils, but there have been problems on soils with very high intake rates, particularly if fields are poorly graded. Depression areas may fill only to have the water soak away before the next surge moves through. There's no way to apply furrow irrigation efficiently under such conditions. Let's talk a few moments about some management adjustments for surge and other situations. We've used the less than half rule to set the amount of soak time after the cutback cycles begin, but that was for systems where tailwater is reused. What about systems that don't reuse runoff, such as those with diked ends? Here, the 3/4 plus rule can be applied. The advance time should be about 3/4 of the total set time. If the irrigator is locked into a 12-hour set, this means it should take 3/4 of 12, or about 9 hours total, for advance. Advance time would be 4.5 hours per side. This leaves 3 hours total for cutback, or an hour and a half per side. Tailwater will be reduced substantially as compared to a surge system set up for reuse. There is one important caution that some surge irrigators sometimes forget. Even if water application is uniform under surge, it can still be excessive. If the irrigator fails to follow a scheduling procedure and irrigates too frequently, or simply lets the water run too long, excess irrigation and nitrate leaching are quite likely. A quick calculation of how much water has been applied can indicate when adjustments are needed. Management of surge needs to be adjusted after the first irrigation. The root zone is deeper, and if irrigations are properly scheduled, a larger water application can be made with less deep drainage loss and nitrate loss. At the same time, intake rates are lower so that the water gets through the field faster. After the first irrigation, set size should be larger. To reduce runoff, more rows per set must be watered, cutting the gallons per minute per furrow. A good starting point is to increase the rows per set by about 1/3. After the first irrigation, the less than half rule should be followed when runoff is reused. To get a uniform irrigation, the amount of time for advance should be less than half of the total irrigation time, giving more than half of the time in the cutback mode. Setting the right cutback cycle time is the key to controlling runoff after the first irrigation. Too long a cycle time will only increase the amount of runoff that has to be handled by the reuse system. For blocked-in furrows, the 3/4 plus rule still applies. It is quite possible to get an irrigation with acceptable uniformity. Setting the right cutback cycle time is critical to avoid a large accumulation of tailwater at the end of the field and the excessive root zone drainage and nitrate leaching which result from it. Surge irrigation used under the right conditions can help the irrigator apply water more uniformly, with less labor, and with better control of runoff as compared to typical furrow irrigation. In this presentation, we've offered some guidelines to help surge irrigators make better use of this new technology. However, the guidelines are just a starting point. To gain the maximum benefits from surge, the irrigator has to learn from experience, adjusting management to fit the constantly changing field conditions.